Welcome to this explainer. I am absolutely thrilled to have you here today. If you've ever stared at a massive math problem and just thought to yourself, there has to be an easier way. Well, you are in exactly the right place. Today, we're not just looking at regular, everyday math. We're going to discover how math actually gives us these superpowered shortcuts to solve massive, intimidating problems. We're taking complex ideas and breaking them down so simply that by the end of this, you'll honestly feel like you've unlocked mathematical cheat codes.
Here is a quick look at our roadmap for today. We'll start off with the magic of doubling, then look at the anatomy of powers, learn the rules of the game, mix and match our choices, tame some giant numbers, and then wrap it all up with a final review and summary. All right, let's jump right into section 1, the magic of doubling. To really grasp why these math tricks are so incredibly powerful, I want to tell you a story about a choice a student named Gautam had to make about his pocket money. It's this classic dilemma that perfectly captures the secret hidden inside multiplication. Picture this, you're Gautam. Your father comes to you and offers a choice for your monthly allowance. Option A is a flat 100 rupees every single day, nice and steady. Or option B, you get just 2 rupees on the very first day, but that amount doubles every single day for the rest of the month. So what would you do? Would you take the steady, reliable 100 rupees or the tiny 2 rupees that promises to grow? Now, at first glance, that flat rate seems so much better, right? 100 rupees is obviously a lot more than 2 rupees. But let's look at how this plays out chronologically. On day 1, you have a measly 2 rupees. Day 2, it becomes 4. Still not exactly rich. But wait until we hit day 10. By doubling every single day, that 2 has grown into 1,024 rupees. That already beats the 1,000 you'd have with the flat rate. And the real magic happens if you just wait it out. By day 30, that daily doubling shortcut rapidly explodes the total to over 107 crore rupees. No way, right? But that is the mind-blowing power of continuous multiplication. And this brilliantly illustrates the fundamental difference between two key concepts: linear growth and exponential growth. Linear growth is what happens when you just slowly add a fixed amount over time, like getting that steady $100 allowance. It forms a predictable, straight line pointing upward, kind of like taking the stairs. But exponential growth, that acts like a math superpower. Instead of adding, it multiplies by a fixed factor, just like our doubling pocket money. It starts off slow, but then it shoots up into this sharply curved line reaching for the sky. It's basically strapping on a jetpack.
Okay, moving right along to section 2, the anatomy of powers.
So to use this superpower properly in our everyday calculations, we need to understand the basic anatomy of these numbers. The absolutely crucial point here is understanding 2 terms, the base and the exponent. Think of the base as your starting number. It's the one doing all the heavy lifting. The exponent, which is that tiny little number floating up at the top right, is like a mathematical instruction manual crossed with a shrink ray. It shrinks down the physical space the math takes up while telling you exactly how many times to multiply the base by itself. So if your base is 2 and the exponent is 5, it literally just means 2 times 2 times 2 times 2 times 2. It saves us from writing out this massive, tedious line of numbers.
Let's move into section 3, the rules of the game.
I'm going to let you in on a little secret. These math laws act exactly like cheat codes in a video game. Seriously. For instance, look at the first law for multiplying. If you're multiplying 2 numbers that have the same base, you don't even need to do all that heavy math. You just add the tiny exponents together. So 2 to the power of 3 times 2 to the power of 4 instantly becomes 2 to the power of 7. Boom. Done. And the 0 power rule, that one's my absolute favorite. Any number, no matter how gigantic it is, if it's raised to the power of 0, it's simply 1. Finally, a negative exponent isn't actually a negative number at all. It magically flips the number into a fraction. It's elegant, it's simple, and it saves so much time.
Next up, section 4, mixing and matching choices. Now, these multiplication shortcuts don't just apply to abstract numbers on a chalkboard. They actually help us organize our daily, real-world choices using a really fascinating concept called combinations. When you hear the word combinations in math, it simply means multiplying the number of options you have at each separate stage. This lets you see all the possible outcomes without having to painfully count them out one by one. It's an absolute lifesaver when you're trying to figure out how many possibilities exist in a given scenario. Let's look at some examples to make this totally concrete. Say you're getting dressed in the morning and you've got 3 different tops and 2 different skirts. Instead of laying every single combination out on the bed, you just multiply 3 by 2. Boom, you know you have exactly 6 unique outfits. Or imagine you're at an ice cream parlor. There are 4 flavors and 3 types of cones. 4 times 3 means that's 12 different ice cream treats you could order. And actually, this is exactly how your phone passcode works. If you have a 4-digit PIN and 10 possible numbers for each digit, you multiply 10 times 10 times 10 times 10. That's 10 to the power of 4, meaning there are 10,000 different possible passcodes keeping your data safe. Pretty cool, right?
All right, Section 5, Taming Giant Numbers.
Because, well, while passcodes are cool and all, what happens when we look up at the stars? Imagine having to write out the distance from the Earth to the Sun in meters. That is 149,600,000,000. Imagine having to write 149,600,000,000 every single time you did a physics calculation. That is a lot of zeros to keep track of. One little slip of the pen, you drop a zero, and suddenly your multi-billion-dollar spaceship crashes into a planet instead of safely orbiting it.
So, to avoid disastrous mistakes with all those tricky zeros, scientists use our superpower shortcut. They use something called scientific notation. It is a brilliant way to shrink really large values down into a clean, simple number between 1 and 10, and then just multiply it by a power of 10. It's essentially taking this giant, unwieldy number and neatly packing it into a tiny mathematical suitcase. It's such a relief.
Here's the simple step-by-step trick to magically convert any messy number into this standard scientific form. First, you just count the total number of digits you're working with. Second, you place a decimal point immediately after the very first non-zero digit on the left. Third, you count how many places are left after that new decimal point. That count becomes your magical exponent. And finally, step 4, you just write your new clean number and multiply it by 10 raised to that exponent. Let's actually see this magic in action. Using this process, that terrifyingly massive distance to the sun simply becomes 1.496 times 10 to the power of 11. It's so much cleaner. The estimated 100 billion stars in the Milky Way, that's just 1 times 10 to the power of 11. And my absolute favorite, the estimated global ant population, which is a 2 followed by 16 zeros, shrinks down neatly to just 2 times 10 to the 16th power. Scientific notation makes everything, from deep space travel to counting microscopic bugs, so much easier to comprehend and compare.
And that brings us to Section 6, Final Review and Summary.
We have covered a ton of ground today, navigating from pocket money all the way to the edges of the galaxy. So let's lock this in. Here's your cheat sheet to take away. Remember, linear growth just slowly adds, while exponential growth uses the magic of multiplication to grow rapidly. The base is your starting number, and the tiny exponent is your instruction telling it how many times to multiply. The laws of exponents are your structural shortcuts, saving you from doing tedious arithmetic. We use combinations to effortlessly multiply options and find our total choices. And finally, scientific notation uses powers of 10 to completely tame the giant numbers of the universe. These are your mathematical superpowers, and now you are completely equipped to use them. To leave you with one final thought on the sheer, almost unbelievable power of exponential growth, consider a standard piece of paper. It's barely a fraction of a millimeter thick. If you could somehow continuously fold that single, thin piece of paper in half 30 times, doubling its thickness over and over, just like Gotham's pocket money, do you think it would reach the top of the Burj Khalifa, the tallest building in the world? Or maybe even higher? Well, I'll let you do the math on that one. Thank you so much for exploring these superpowered shortcuts with me today. Keep questioning, keep calculating, and I'll see you next time.